Hey boys and girls, this is a little different type of a program that I'm going to be putting on today. What I've got is some people who've never really gone through the training here at Munro yet. So I'm going to give them a little bit of a background on how we actually design products at Munro, and I'm going to compare them to the philosophies that Elon Musk has kind of sorted out since he started working on the Model 3. I think that what's going to happen is you're going to hear from Elon Musk, and we've been doing something similar to what he's going to say in this little book for about 30 years. So I can tell you for sure that people normally, what happens is people normally will get into a situation where they learn these lessons, but they learn them the most expensive and hard way. And right at the end, you'll hear a little blurb from Elon Musk saying exactly that. So what I'm going to do is I'm just going to go through this stuff. We're going to be doing this just like any other little workshop, but there'll be a slide that'll pop up with Elon Musk's comments on it to show you how what we do and what he's figured out kind of like are the same thing. So with that, let's get moving. And the reason that I'm doing this is because of this article right here. I thought this was quite good. It's from Inside EVs, and I read that all the time. And they posted something that came out of Evanex. I hope that's right. And Evanex makes and sells aftermarket accessories. And what they did was they wrote an article about what Elon Musk had said. And I thought it was brilliant. And so I thought, you know what, I'm going to build on this. I'll give these, oh, and by the way, aftermarket accessories, that means that if you go there and you have a Tesla, you can buy some of these aftermarket accessories. So that's their commercial. So anyway, Munro & Associates is a company who has a symbol that gets confused. People think that it's a triangle sitting on its ear, but really what it is a less than symbol. We found that if we can get less parts, less operations, less tooling, less quality problems, it's going to be better for the customer. And quite frankly, that's why it says value to the customer, quality for the customer, and profit for the company that's making the products. We're in the business of innovation at Munro. Now that's kind of bold statement, but at the end of the day, we didn't create that. We were given that by the folks over at NASA. NASA calls us an innovation factory. And if you look around in here, this is something that NASA gave me for an innovation speech I gave. And if you look at the cabinets on either side of me, they're full of things from NASA saying, hey, thanks for the memories. What we do, or the reason that we can innovate and bring new ideas to the folks over at NASA, is because we benchmark the world. We've worked on everything from Barbie to the space station, and that's where we get great ideas. Ideas that we can take from one industry and bring to another and break the paradigms in that new industry. Because without that outside intervention, you'll never get anywhere. So we found that if we benchmark, if we know ourselves and we know our enemy, we'll win every battle. This is a great phrase from a book called, or a book written by General Sun Tzu. Sun Tzu wrote The Art of War, and this is the premier phrase that comes out of that book. Now, there's high five that go along with benchmarking. So identify what you do, how well you do it, and in Sun Tzu's words, know yourself. And that means everything, and you've got to be honest about it. In fact, as a rule, it's better if you get somebody else to look at you, because it's very difficult to see the speck in your own eye. After you've done that, identify who's doing whatever it is that you do best, and then analyze their product. So now you know your enemy. You know your enemy, and you should know them right down to the last detail. How much do the nuts and bolts cost? You want to find out what the differences are, determine the gaps between best and your company, analytically. In fact, what I'm going to talk about in a while is that if you don't have numbers, you don't know what you're talking about, and that came from Isaac Newton. When you dissect a competitor's product, learn from the best, adopt, implement the newfound best practices quickly. Be the best of the best. But don't stop. Don't stop. You have to continuously get better. Become the best of the best, no excuses. But here's the warning, don't stop. Continuously improve because you don't want to become overtaken. If you think about it, what happened to the Sony Walkman? Right? Everybody had a Sony Walkman at one time. And then they were put completely out of business by Apple. Why? Because the Sony Walkman folks decided that they wanted to stay with rotating memory, right? Something that spins or something was on tape, rotating memory, and everybody else, or let me rephrase that, Apple went to solid state memory. And by doing that, they made a huge change in the marketplace, made the product even smaller, and basically eliminated the world leader completely from the market. Apple did the same thing to BlackBerry. I can remember a time when no one had anything but a BlackBerry phone. Now you can't even find one. The other thing we want to do is we want to have some basic ground rules. So Dr. Edward Demings is the guy that asked me or told me to get into business for myself. And he said, as variation is reduced, quality will increase. And I say that all variation comes from design. If we can't come up with a design that's simple and easy to manufacture with the least amount of pieces or parts or operations and the lowest cost for implementation, we'll never ever get into business. And then I need numbers. Sir Isaac Newton said, if you have no numbers to support your theory, you know not of which you speak. I think that what you really need to do is you need to have these founding principles, these basic ground rules in back of you before you even start thinking about what's going to happen next. So, as I said, benchmarking is a good idea because great ideas never come from the inside. Great ideas come from the outside. Is that true? Well, I don't know. Let's talk about what Elon Musk says. I think it's important to reason from first principles rather than analogy. The normal way we conduct our lives is reasoning by analogy. With analogy, we're doing this because it's like something else that was done, or it's like what other people are doing. With first principles, you boil things down to the most fundamental truths and then reason from there. Okay, so let's just try and put this into context. Who invented the airplane? The Wright brothers weren't even bicycle builders. They were bicycle repairmen. Why didn't the French come up with the first airplane? After all, they had invented gliders and they had invented hot air balloons and all this other. Why didn't they invent it? They had PhDs running around. And yet it was two bicycle repairmen who were using first principles in order to get to where they needed to get to. The telephone dialing system was invented by an undertaker. And the reason for that was because the lady who was in charge of the switchboard in the olden days, her husband was an undertaker, and so anybody that died, she shifted him immediately there. And he wanted to have something that was going to allow him to get more work. The phonograph was invented by a sweeper in Edison's lab. The sweeper banged an experiment that he had. Edison noticed that there was a playback. It made noise when he tried to reset the experiment. And from there, it went from there to what we have. Well, no, that was the first step in what we have now as far as recordings. And then fast-drying paint was invented by an electrical engineer. Boss Kettering invented fast-drying paint simply because they had thousands and thousands and thousands of cars sitting in the parking lot waiting to dry. Even Henry Ford's assembly line came from an unlikely spot. It came from a slaughterhouse. Henry Ford flew over the top of a slaughterhouse in Chicago, looked out the window, saw cows going in one end and Hamburg coming out the other. From that, he figured, if I can disassemble cows on an assembly line, disassembly line, why can't I build cars on an assembly line? So if you go back to first principles, it's much easier to come up with an invention or an innovation than it is if you try and just do what everybody else has done. And I'm going to show you lots of examples. So our idea of the best design, according to Albert Einstein, it's the simplest one that works. But what we found is the first design is never the simplest. The simplest design never has the highest quality. So we go back and we do reiteration after reiteration, going back to challenge each and every part, every one of the different operations, the quality, everything that's associated with a product, so that we can get the absolute best, lowest cost product into the marketplace. Now, on some of these things, I've talked about how we work with Club Car, and they went from 32% market share to 80% market share. How they could increase their their prices because people were willing to pay for a product that actually cost less to manufacture. It cost less to manufacture, but it had so many more features. It had so many more features because what we did was we eliminated things that everybody thought or had in the past was, oh, well, we can't do that, or no, that's not a way a golf car is supposed to look, and added those features and functions that made such a dramatic difference for them that they dominate the marketplace. This is the kind of thing that you need to do, and you can only do it at one point in time. You have to do it at the design phase. Product design, material, labor, overhead, these are the things, these are the cost points that we always look at in order to determine whether or not our product is going to be successful in the marketplace. The problem is most people do this gauging after it's done. With Munro, we do this at the beginning of the program, at the sketch stage, when things are still simple and fluid. And what we found is, and this was found at Ford Motor Company when I was working there in finance staff, what we found was that 30% of our cost was overhead. So that's buildings and people that run the operations. 15% was labor, 50% was suppliers, and 5% was product design. We only spent 5%, and yet the company was always trying to squeeze that 5% down. They wanted to get rid of as much of that as possible, farm it out. The problem is that if you look at the influence that these things have over your profitability, customer acceptance, every aspect that's associated with a product, if you look at that, you find out that overhead, 5%. No matter which building we looked at, it's about 5% influence. Labor, about 5%. Now material is 20%, and the reason for that is because actually if you think back with Ford, they had the Firestone issue. They had tires. It damn near wrecked the Explorer line because of a tire that was supplied by some outsider. So that's 20% over your ability to make money, as it were. And then this guy down here at 5%. He controls 70%. 70% of your ability to make money, 70% of your customer acceptance, 70% of everything that has to do inside the factory. How many forklift truck drivers are you going to have? How many pieces of paper are going to fly around? How many people are going to be in that company? And what kind of lifestyle are the people on the factory floor going to have? How many of them are going to have ergonomic issues that are going to break their back? This guy's got it all. This is where you want to concentrate your efforts, and you want to do it as early into the process as you possibly can. So, where do we start? Specifications. Question everything, believe nothing. That is the rule at Munro & Associates. Question everything, believe nothing. Now, that's a sketch. That sketch was to help us get going on a product. Ooh, this product right here. This monster right here was how we started to develop a new product. The company that we were working with, IVAC, they were going out of business, slowly, but going out of business. This product is heavy enough that if I gave this to Kim, she would probably not want to hang on to it for any length of time, and neither do I. What did we come up with? We came up with this sketch. This is totally different than anything else that's ever been in any of these products. Totally different. Why? Because I had benchmarked other products, And when I came to look at what their problem was, and we wrote down the problems on a piece of paper, and they said, well, we have to do this, we have to do that, we have to do this, and we have to stay away from that and stay away from this and stay away from that. And I asked, why? Well, legal issues or cost or blah, blah. Nobody can do it. That's where I wanted to go first. Those are the sacred cows, and those are the things that I want to kill first, because sacred cows make the best steaks. And how am I going to come up with new answers? By going outside of the industry. So I looked at their specifications, I basically threw them out, and we started from scratch. We started with a blank sheet of paper, and we started putting down those things that we'd like to have, needed to have, and wanted to have. That's how you start, really. Those specifications then will tell you how we're going to do what the job is, but you don't look at is the old product. The old product is not going to be your friend anymore. That sketch, that sketch right there is what turned into this. Now, what's the difference between this and that big box that I was just holding up? This is made out of 100% plastic except for the electric motor. That one was made out of stainless steel. Oh, we have to have stainless steel. Why is that? Well, because it has to go into a steam bath. It has to be sanitized. I can sanitize plastic. Oh, no, it can't work. This just can't. There's no such thing as a medical grade plastic. There's thousands of them. Are you sure? This one here weighs almost nothing. The one over there weighs quite a bit. And what happens when it goes into a sterilizing unit? When that big giant box goes into the sterilizing unit, the plates, the stainless steel plates that are in the peristaltic pump that this thing uses, they expand and contract a little. All the dirt goes in between them. Capillary reaction brings in all the dirt, puts it between the two plates, and now what happens? They get stuck together. Now when you turn it on, it tries to move, and it breaks the crankshaft on the peristaltic pump, and now you've got a piece of junk. This is plastic. Plastic loves steam. It soaks it up. It makes it lubricating. This is the kind of thing that's perfect. This is the perfect design. This has a little doodad down here, this pressure transducer. We were told that it's impossible to make neonatal. Neonatal means that these are for babies, basically. And that's not possible because we can't possibly measure to that accuracy. And I had just come off of a program for the Defense Department, and I already knew that that was baloney. I could measure to micron sizes these guys couldn't even dream of. We added that. We put this in, and we wound up with this sketch. How long do you think it took? Anybody? How long? How long to go from that big box right there, skipping all the training and the arguing and stuff like that, from, okay, let's do something, to after like that includes writing down our new specifications and whatnot, to having that sketch. 3 days. 3 days. And you know what 2 of them were sorting out? Trying to convince engineers that they could do the job, and trying to convince that marketing and the marketing people and the lawyers that they were wrong. It really should have taken 1 day. For me, I looked at that, and I thought about it, and I came up with this, and that was in about 20 minutes. I knew we could do it. This, by the way, was done on a paper napkin, or actually, it's not a real paper napkin, it's an actual napkin at a restaurant that we were going at, and in essence, half the team didn't even want to be there. They didn't want to come. So it was the team that was left, the ones who were enthusiastic about change, that came up with this idea. This is the kind of stuff that can make good things happen. So what was the good things that happened here? This is the product. This product took on the marketplace and in essence dominated. It didn't just dominate, it eliminated, annihilated the competition. Annihilated. We wound up having to put the first factory up. We had one factory. We set that factory up. We had one shift, then it went to 2 shifts, then it went to 3 shifts, then we put up a second factory in the US. Then we put up a factory in, Ireland, and then another factory in Japan to take care of the Eastern market. We put everybody else out of business. Why? Because we moved quickly. Speed is a big deal. So when you look at this sort of stuff and you say, well, what would Elon say? Oh, sorry, this is the method. Doing it right up front in the new product development phase. New product development is as far upstream as you can possibly get. And here's what Elon says. Now, he says, make the requirements less dumb. Step 1, make the requirements less dumb. What's the difference between question everything and believe nothing? Dumb requirements are especially dangerous when they come from a respected individual. Who did I argue with? Lawyers, marketing guys, engineers that have been around for a long time. You have to be firm when you're taking on the planet, or you're taking on the company that you're working with. You cannot be timid. You have to be strong, and you have to be able to put forth your ideas because you're right and they're living in the past. That's how it has to work. Everyone is wrong sometimes, and those with strongly held rules and regulations, like lawyers, like marketing people, and like engineers who've been around the job for a long, long time, they're the ones who are very difficult to change their minds. So Munro's philosophy is a little different than everybody else's. Our philosophy is seeing what everyone else has seen, but thinking differently than everyone else has thought. And that's what happened with the Wright brothers. They watched flight along with man since like millions of years ago and wished that they could get off the ground. But they didn't use any feathers, and these wings don't flap. You have to think differently sometimes to get the objective that you're looking for. So let's look at what happens when you have people with strongly held rules and regulations in the aircraft industry. What you're looking at is the cockpit for the MD-11, McDonnell Douglas. That used to be an airplane company. McDonnell Douglas had this. It was kind of an update of an old World War II bomber. It had great big giant seats in it because the guys that flew great big giant bombers were great big giant guys. That and the fact that these things are all mechanical. These yokes, they go to basically wherever it is that you want to move. So ailerons, rudders, flaps, all these things are controlled through here. So you have to be a fairly strong guy to make all these things happen if the power goes out or if you're not flying on autopilot. It looks archaic. Steam gauges, lots of knobs, and who knows how do you manage this thing? We were chartered by one of the VPs over at McDonnell Douglas, and she asked us to find a new way. What are we going to do to enter the market in a civilized and better fashion than what we've got going on here? This is what we came up with. This is a combination of Munro, McDonnell Douglas's best engineers, as far as I was concerned, and the California Art College. We came up with this. Look at that chair. Anybody can fly this plane, anybody, because that chair is going to accommodate everybody from 1 percentile up to 99. That's a big deal. That doesn't sound like much, but it's a huge deal. This plane is flown with a side stick, so it basically flies by wire. This plane has only a few dials up here, only a few. And basically, if you use that one and you keep the brown down, you probably won't crash. The brown is the ground, the blue is the sky. Just checking to see if you're paying attention. Okay? Everything here, simple, easy peasy. See that right there? That was one of the things that we thought was just genius. It's a drawer. Half the dials that you saw a few minutes ago, they control things like the that ground crew is interested in, but when you're flying, you don't care about. They all went into this drawer. So when ground crew was there, they opened up the drawer, didn't bother the pilot or the co-pilot. They did whatever they needed to do, looked at whatever they needed to look at, closed the drawer, and away you go. Clever idea. What do you think happened when the executives from McDonnell Douglas came in and saw this? By the way, this is full size. We cut the nose off of an old airplane so that we could make this. What do you think the executives said when they saw this? Huh?
They rejected it.
Rejected it? Better than that. First, they fired me. Then, they fired the California Art College and refused to pay them. Then, they fired the people that were on the project. That's what happens when you've got strongly held rules and regulations and you're staring at the future. What do you think this is? That was the first sketches that came out of Airbus for the A380. Look at that seat. Look at that cockpit. Look at that drawer. How in the world did they come up with exactly the same product as what we did? Because McDonnell Douglas was so convinced that it was a stupid idea that they actually published the pictures of the prototype. That's what happens when you have a strong paradigm going in the wrong direction. You are going to fail, and you're going to fail big. And that's why McDonnell Douglas is now called Boeing. And there is no such thing as an MD-11 or anything else. They could have been on top, but they weren't. Now, I mentioned that there were 3 groups that had been fired, but there was a fourth, and that was Bonnie Sudik, this lady right here. Bonnie Sudik said, if we argue hard for our limitations, we'll get to keep them. And she got sacked as well. Where did she go? Boeing. That's kind of like what happens. Your best talent will walk out the door if you don't decide to do something that's really, truly worthwhile. Now comes a little ad for Munro & Associates. We're short about 20 people, and I need good engineers that are interested in doing things that are different than what everybody else does. And so consequently, you can go to Munro Live, YouTube at the bottom, and you can send a little something in that says to sales and send us your resume. This person shouldn't have got sacked. She should have been listened to along with everybody else, and there still might be a McDonnell Douglas. But when you have a president of marketing and sales, a president of engineering that just basically arbitrarily throw out, nah, that's stupid, get rid of these clowns, we got to get back to the good old days, you'll find yourself in a situation similar to the ICE OEMs right now, thinking that somehow, some way, the good old days will return. So, sometimes when you get into a design, engineers will tell you that they don't need to use this tool that we've got, Lean Design Tool, because they're going to use robots. But I'm going to tell you, I came from the robot industry, and robots, to put things together, it's a lot more difficult than getting a human being to do the job. So at the end of the day, we found that if anybody, everybody, should be designing for a robot, but you might not be, at the end of the day, using a robot. So why is that? So why did Tesla, this was written a while ago, why is Tesla failing to deliver its car? Well, Leonardo da Vinci invented this drumming robot. It's an animatron. What was his real objective, though? Well, he wanted to have soldiers that would fight all Europeans' wars. And that is a model of the soldier that he came up with. The problem is the soldier did this, and anybody could come over and whack it, and it would fall over, and that'd be the end of it. There wasn't going to be any robotic knights. Next guy up was in 1985, Roger Smith, CEO of General Motors, thought that robots would be able to replace all of his assembly line workers. What a disaster. I can remember flying over the top of the Cadillac plant in Hamtramck in an airplane headed for California. And we looked out the window, and here's what we thought was a great big giant reflecting pool in the backyard at GM. It wasn't. It was all the robots that Roger Smith had purchased for that plant and said, here, some robots, get them going and throw them guys out. Well, it doesn't work quite like that. They took the robots out after they figured out that they'd failed, put them in the backyard and put them under visqueen, plastic wrap. From the air, it looked like a reflecting pool. Up close, not quite so much. That was a failure. And then in 2015, Elon Musk thought that robots would replace all the assembly line workers. And at the end of this, I'm going to tell you, Elon Musk actually admits that he did everything backwards the first time. He failed as well. You cannot just arbitrarily get a bag of robots and get them going in your factory unless you've designed for them. And how do you design for them? Why did they fail? Because they didn't design for Bob, the blindfolded one-armed builder. So when Munro and Associates works with anybody, we want to make sure that every product that can be built by a one-armed guy. A one-armed blind guy, actually. And if you can do that, then okay, you can make it happen for robots. But you know what? In a lot of cases, there's no ROI. There's no return on investment. And so consequently, what winds up happening is you can do it with robots, but you'll just put people there instead because they can do it faster, better, and cheaper. So here's what Elon Musk said. Step 5, and this is the 5th one. So I've kind of like took the 5th one and brought it up because this is where it really means something. Automate last. I have personally made these mistakes of going backwards on all 5 steps multiple times in making the Model 3 automated, accelerated, simplified, and then deleted. It was like being in a Dilbert cartoon. Elon just verified what I just told you. But I'm going to tell you that he inadvertently has been designing for Bob, the blindfolded one-armed builder. Now, in the case of, let's say, all of those bits and pieces that would go into the rear end or into the front end of the vehicle where it turned into a great big giant casting, guess what? That is a classic example of what you can do and how you can do it for a Bob kind of scenario. Because look at all the parts that are missing. Look at how easy it would be. And by the way, sometimes what you do is you say that Bob's got an infinitely strong arm. All Bob has to do is pick it up and put it down. Perfect for a robot. So how do we get to the least number of parts? And that's because, or this is the way we do it here at Munro. We call it the part value challenge. And so this is the little card that we use to challenge each and every part inside of a product. So the first thing we ask is, does the part have to move? I don't care if it moves right now, because that's something that's been happening for a while. I want to know, will it move, or do I need it to move, or does it have to move? The second one is, does it have to be a different material? Again, I don't really care if it's a different material right now. Does it have to be there? And then, if it looks like a spring or it looks like a fastener of any kind, screw is shown, but could be a rivet, could be almost anything. If it's a slave fastener, it's a candidate for elimination. And the last one is get rid of belts. All belts basically are bad. It'd be better if you had something that would be a direct drive. And guess what? One of the reasons why electric cars will last a lot longer is they have 2 gears where other people are going into 7 and 9 gear transmissions. And there's lots of parts in there, and those parts are all going to fail eventually. So, and then the last thing is, when in doubt, throw it out. Challenge yourself. The idea is it's a part challenge. A part challenge. How do I challenge what I'm doing? If I don't have some way of challenging myself, this is a good candidate. This is a good way of trying to make it happen. So what can you do if you do this kind of designing? Well, this is one of our guys, Bill Sprague. He's putting together a point-of-sale cash register. He's got a blindfold on, and he's got parts that he's putting together. Now he's using his hand as a fixture, but one hand is basically putting everything together. He, with the Bob design card, got rid of 80% of the parts, 66% of the suppliers, 83% less assembly time, 44% lower manufacturing costs, less time to repair, but also more reliable. 60 seconds to put the whole things together, and that's blindfolded. And then more screws in the old design than there were parts in the new one. As soon as an engineer has become lazy and decided to use screws, you're going to get a product that, quite frankly, it will be inferior. So, Elon Musk, what does he say? Delete parts of the process. Try very hard to delete parts. The bias seems to be, let's add this part or this process, just in case we need it. Put a name on every part that's added. In other words, somebody's physical name. So Jack wants this part. And the reason for that is because if you put a department or you put something else on it, then nobody is responsible. You have to have somebody responsible for any part that doesn't really meet the criteria. Put a name on it. And by the way, you find out that after a while, people don't want their names up there because nobody wants to be responsible. Cut down the number of parts.